Let's just review what polygons are. Polygons are created by straight segments, and the polygon with the minimum number of sides is called a triangle. It has 3 sides. You may recall that the sum of the 3 angles of a triangle is 180 degrees. Now we're going to use that fact to figure out what the sum of the triangles in convex polygons is, the sum of the interior angles. So if you take a look at this sketch over here, you've got 6 angles and you've got 6 sides. This is a convex polygon, and with 6 sides, if I start drawing a diagonal is something that connects 2 non-consecutive vertices. So that's one diagonal, and this, okay, one diagonal. That didn't draw that too well, but that's okay. And we have another diagonal, so we're going from the same vertex to non-consecutive vertices, and we could also draw in a third diagonal. So we have 3 diagonals and we have 4 triangles. We have 6 sides. 1, 2, 3, 4, 5, 6. So we have 6 sides. We have 4 diagonals. I didn't mean that, did I? What I mean is that we have 4 triangles, and we have 3 diagonals. Okay, so if there are 4 triangles, then you know that the sum will be 4 times 180. Well, look at the formula over here. You get 4 by taking and subtracting 2 and multiplying that by 180. This is the number of triangles. So any convex polygon, take the number of sides, subtract 2 from it, that gives you the number of triangles, multiply by 180, and that gives you the sum of the interior angles. So very quickly, which are the interior angles? They were labeled here: 1, 2, 3, 4. 1, 2, 3, 4, 5. And I'm not going to mark the 6th one because there are too many arcs. What this diagram is showing is that all these angles are non-congruent. If the angles were congruent, we would call this an equiangular polygon. If the sides were congruent, we would call it equilateral. If you have both an equilateral and an equiangular polygon, we call it regular. Regular means all the sides are congruent and all the angles are congruent. That's just vocab for you. Interior angles of a quadrilateral. Well, we know that a quadrilateral has 4 sides. So this looks like a rectangle. And it doesn't have to be a rectangle. It can be any number of sides. So if I take a vertex, I can create 2 triangles from it, and 2 times 180 is 360. The sum of the angles of a triangle is 180. The sum of the angles of a quadrilateral, any quadrilateral, square, rectangle, any 4-sided polygon is 360 degrees. And those 2 numbers are very useful to remember. Exterior angles theorem. At each vertex of a polygon, there you can create 2 two exterior angles. But what we'll deal with is one exterior angle at each vertex. So 1, 2, 3, 4. 1, 2, 3, 4, 5. 5. So there are 5 exterior angles here. In a convex polygon, it is irrelevant how many sides the polygon has, but the sum of the exterior angles of any convex polygon where we only count one angle at each vertex is 360 degrees, and this does not change. If you think about this polygon and you think of it contracting towards the middle, then all these angles would sort of come together at one point, and at one point, the angle measure here is 360 degrees. What you can do is take a pair of scissors and start cutting all the sides parallel to the original polygon, and eventually you'll get left with a really tiny polygon, and eventually you'll get left with a point, and the angle measures 360. Okay, this one, just apply the formula. Sum of the measured interior angles is 2340, so you're going to set n minus 2 times 180 degrees equals 2340. Divide both sides by 180 and then solve for n. Find the value of x in the diagram. So what you'll do first is find the sum of the interior angles. So you'll say sum of interior angles equals n minus 2 times 180. You find that number, and then you'll add all the angle measures and make it equal to whatever you get here. Okay, and that's all for x. This one is just talking about the exterior angles of a polygon, a convex polygon, and you need to recall the theorem which tells you what the sum of the exterior angles of a quadrilateral is. So this is a pretty easy section. So just do the problems, and good luck.